Hello my dear student, welcome to Nagesh Karasge Orchid School channel. Myself Hina Patel going to teach you 7th grade mathematics. Already we had started with exponents and powers. Some more example today we will try to solve the simplification of an exponents and power in the form of an exponential format. So, we will have one example here. Already I had written one example, now you will help me to solve out this example. Here already we had learned the laws of powers of an exponents, exponential form. Here we are having the 5 raised to the power of 2 to the power of whole is given as 3. So, which type of a law or which law we have to use here, and it is given in the whole bracket divided by the 5 raised to the power of 7. First we will simplify this bracket because it is given in the square bracket. First we will try to simplify a round bracket, that is, when power to the power powers are multiplied. So, we write as 2 into 3 multiplied by 5 to raised to the power of 4. I will write as it is, which is written as divided by 5 raised to the power of 7. Now, this multiplication very simple, it is 2 times 3 is 6 into the 5 raised to the power of 4. I will write as it is in the form of, here I will write as 5 raised to the 7. Now, here you can see that when the base are same, that is 5 raised to the power of 6 and 5 raised to the power of 4. Here we are having the base same, so you can write a common base and you can add the powers. Divided by 5 raised to the power of 7. Now, what will be the answer of this? Is 5 raised to the 6 plus 4 is 10 divided by 5 raised to the power of 7. Now, how to write when it is in the division form? You know that when the base are same, we have to subtract the powers. So, we will write here as 5 to the power of 10. Here both the base are same, so we have to subtract. So, I will write minus 7. So, what will be the here? 5 base and 10 minus 7 is 3. So, what we will get at the simplification of a power to the power into the power 5 raised to the 4 divided by 5 to the power of 7. So, step by step we had used the laws of an exponential and we have tried to simplify a given question. So, in this way step by step we can simplify by using the laws of an exponents. So, we will have another examples here, which is given as 3 into the 7 raised to the 2, that is we can say it is 7 square multiplied by 11 raised to the power of 8 upon 21 into the 11 cube. We can say when it is a 3 we can say cube, when it is a 2 we can say a square. Here it is given as 3 multiplied by 7 raised to the power of 2 into 11 to the power of 8 upon 21 into 11 power of 3 or 11 cube. Now, what we have to do here? Here we are having some common base, that here is 11, 11. How to simplify 21? We will try to see here. 3 multiplied by 7 into 7, which is written as the 7 square, is written in the expanded form as 7 into 7 into 11 raised to the 8, and in the denominator is nothing but in the form of a division we have 11 cube, which will be subtracted here, that is 8 minus 3. What is left is 21 is left here. So, after doing this, 7 into 3 into 7, what we can do? We can reduce here, at is 7 ones are, here 7 threes are, here 3 get cancelled. So, what is left? Only 1 7 is left after reduction. I told many a time, when it is in the form of a fraction or in the numerator and the denominator, if it is possible to simplify, we have to simplify and reduce it. So, what will be left here? 7 into 11, 8 minus 3 is 5, the fifth power of 11 we can say, 11 raised to the power of 5. So, in this way we had tried to simplify. If you write here as 21 in the form of 3 into 7, that is also correct. What we had done? Just we had written in expanded form. Here another example, 3 raised to the power of 7 upon 3 raised to the power of 4 into 3 cube. Here you might be seeing that all the base are same, but step by step we will do here, that is 3 raised to the power 7 upon, here both the base are same, the powers are added. So, 4 plus 3 we are adding here is 7. So, 3 raised to power of 7 and 3 raised to the power of 7. Now, you know that when it is in the denominator is nothing but it is in the form of an division. So, here the base are same, that is 3, we will write 7 minus 7, that will be 3, 7 minus 7 is 0. So, 3 raised to 0 is written as a 1. So, you can write 3 raised to 0 or you can write as 1. I had told that time by taking the variable as a, I had explained you this. So, it will be more easy to understand when we have a variable. So, it will be applied to any number. So, in this way we had seen 2 more examples. Now, we will have another example here which is given as powers, as well as we had seen the numerators or with and variables. 2 raised to the power of 8 into a raised to the power of 5. Here we are having a variable as an a. Here upon 4 raised to the power of 3 into a raised to the power of 3. Now, you can see here we can see having the base same. Here how to write a 4? You know now, because we had seen with some example in the starting of this introduction that 2 square is 4. So, we will write as 4 as 2 square to the power, that is 3, because already it is 4 raised to the power of 3 it is. So, we write as 3. Now, it is nothing but power 2 raised to the 2 to the power 3. So, now when its power to the power is multiplied, that is 3 2s are 6. Now, we will try to solve here, that is 2 raised to 8 into a to the power of 5 minus, because here the a is base is same, the power when it is in the denominator it will be subtracted. So, minus 3. So, 5 minus 3 is 2, we will write as it is a raised to the power of 8 into a raised to the power of 2 upon 2 raised to the power of 6. Already I had explained you this. Now, you will see here the base are same, that is 2 and 2. So, what will be done? Powers will be subtracted. So, 2 it is in the form of a division. So, we write as 2 raised to the power of 8 minus 6 into a raised to 2, or we can say a square. Now, after subtraction 8 minus 6 we get as a 2. So, we can say 2 square and a square. Now, here base are different, a and 2 are different, but powers are same. So, we write as a common power taking this 2 base as 2a to the power of 2, or we can say it is a square. So, in this way we had used many different types of laws here of exponential to write in exponential form, which we had done the simplification of it. Now, we are having some more example, we will try to solve here on the board. So, is given as 25 raised to 4 divided by 5 raised to 3. So, we will try to solve here on the board one by one. So, example number 4 is 25 to the power of 4 divided by 5 to the power of 3. Now, how to write a 25? Is written in the square form? Yes, you are right, is nothing but 5 square. 5 square is nothing but 5 into 5 2 times, 5 5s are 25. To the power, it is given as 4 divided by 5 raised to cube, or we can say 3, 5 cube. Now, power to the power, which is multiplied here, divided by 5 cube. What will be the multiplication? 4 2s are 8 divided by 5 cube, as it is we will write. Now, here the base are same, but we are having the division here. So, what should be the power should be done as subtracted. So, what we will write here as 5, here both are same, but it is a division. So, we will subtract the powers, that is 8 minus 3. So, here what will be the answer? 8 minus 3 will be 5. So, what will be the answer is 5 to the power of 5. So, in this way we had done the simplification of this, because first we have to write in its expanded form of 25, which is written as 5 square. Then we had find out the power, and after doing the multiplication of that 5 to the power of power, then we had find out a division sign which is divided. So, it is always written in the form of an subtraction. So, we will have one more example is 3 raised to the power of 7 upon 3 raised to the power of 4 into 3 raised to the power of 3. It is very easy. What we will write? All the bases are same. Step by step we will do it. First we will write as it is 3 raised to the power of 7. Here both the base are same. So, we will write a common base and powers will be added. So, we write as 4 plus 3. Again 3 raised to power of 7 and 3 raised to the power of 7, that is 4 plus 3 is 7. Here we have written the 3 raised to power of 7 upon 3 raised to the power of 7. Now, here both the bases are same. So, power should be subtracted. We will write this 3 common, 7 minus 7. 7 minus 7 is 0. So, we will write as 3 raised to 0, or we can say that already we had learned that a raised to 0 is always 1. So, we can write or it is nothing but 1. So, after simplifying this step by step using the laws of an exponents, we have tried to simplify and we got the answer as a 3 raised to 0, or we can write as a 1. One more example which is very easy, I think so orally also you can do it. Just I will write the question of this. So, within a 1 or 2 step we can solve this. The 8th one, 2 raised to 0, 3 raised to 0, 4 raised to 0. Now you know, already we had learned that a raised to 0 is always 1. So, in the place of 2 raised to 0 we can write as 1, into 3 raised to 0 we can write as 1, into 4 raised to 0 we can write as 1. Now, it is 1 ones are 1, 1 ones are 1. So, it is 1. Sometime here may be a addition. So, you have to take care of this. Now, 2 raised to the power of 0 is 1, plus 3 raised to the power of 0 is 1, plus 1. So, 1 plus 1 is addition. So, answer will be 3. Do not be confused in the sign when it is given as a multiplication. Always 1 ones are 1 and 1 ones are 1. So, in this way it was very easy to solve the steps, because we know some laws of an exponential form. One more example we will see here is 2 raised to 3 into 2 to the power of 2. 2 to the power of 2. Now, you know it is common already in the previous session I had explained you, it is a common power, that is we can say this square, we will write it will be belong to this as well as this. So, what we will write here, 2 raised to the power of 3 or 2 cube to the 2 into 2 to the power of 2, that is 2 square. So, we can say now it is power to the power, you know that we have to multiply. When the base are same, we do the addition in the numerator, and when it is a denominator or the division, when base are same, we do the subtraction. Here what will be here? We will write as it is 2 square. Now 3 times 2 is 6 into 2 square. Now here we have a base same, we write as a base as a 2 and powers will be added. So, we write as 6 plus 2 is 8. So, in this way we had tried to simplify step by step using a powers, exponents and powers, the laws, and we have tried to solve it. Now, we will have some more example, true or false, and justify your answers. Can we say directly it is a true or false? No. So, first we have to try to see the base as well as its power. Here we are having one example is 10 multiplied by 10 to the power 11, or we can say its 11th power of 10, which will be here it is 10 is having a nothing but 1 as a power. So, what we write as? We write as a 11 here. So, step by step we will see 10 raised to 1 plus 11, because here the both the base are same. So, power should be added, we have nothing here means it is 1, it is not a 0. So, here we add the power as 1 plus 11, which is given as a 12. That is RHS is equal to 100 raised to the power of 11 is equal to, we can write as a 10 square to the power of 11. And LHS is given is nothing but now the powers to the power. So, we do a multiplication, that is 10 to raised to the power of 22. Now, we have to see that 10 raised to the power of 12 is not equal to the 10 raised to the power of 22, because here we have to say that statement given is true or false. If it is false, we have to justify our answer. Now, I can't say that it is LHS is equal to RHS. First, I have tried to solve this. It's LHS, you know that what we got is in LHS is 10 to the power of 12, and RHS, which we had tried to find out in the form of a base as a 10, but we had got a power as a 22. So, we can say that 10 raised to the power of 12 is not equal to the 10 raised to the power of 22. Therefore, the statement is false. We had tried to justify by finding the simplest form of an LHS and RHS. Now, one more example we are having here is 3 raised to the power of 0 is equal to 1000 raised to the power of 0. I told when I was explaining some rules of exponential as a raised to the power of 0 is always 1. So, a may be a 1 digit number, it may be a 2 digit number, it may be a 3 digit number. It is a variable, so it may vary. Now, 3 raised to the power of 0 is nothing but 1, and 1000 raised to the power of 0 is also 1. So, 1 is equal to 1, that is left hand side 1 and right hand side 1 is equal to 1. So, we can say that a statement is true. So, we had justify if the statement is true as well as if the statement is false, we have tried to justify and given the answer. Now, we are having some examples which are very important from the examination point of view and which will help you to find out in a exponential form. You might be seeing that 108 into 192, it is not a simple multiplication. Just read the question properly, express each of the following as a product of prime factors only in exponential form. So, we have to express this in the exponential form. How to write this in a exponential form? Already I told you we have to find out a prime factors. Now, we will find out the prime factors by division method, that is 108. It is an even number, so it is divisible by 2, giving as the remainder as a 0, as a quotient as 54. So, again 2, that is 27, 3 9s are 27, 3 3s are 9 and 3 1s are 3. Now, we are having here the factors as 2 into 2, 3 into 3 into 3. Same we have to find out the prime factors of 192 by a division method. Now, you know now it is an even number in the ones place, so it is divisible by 2, giving a remainder as 0 and 96 as a quotient. Again we will divide by 2, giving a quotient as 48. Again it is the even number, so we will divide by 2, we will have a quotient as 24. Again it is even number in the ones place, so we will divide by 2, which quotient will be 12. So, 12 is divisible by 2, so it is 2 6s are 12 and 2 6 can be divisible by 2, which give as 2 3s are 6 and 3 1s are 3. Now, we have to write all the factors of 108 and 192, that is 192. So, we will write all the factors which we had tried to find out by division method, that is 2 into 2, 3 into 3 into 3, we had written the factors of 108, then we will write 2 into 2 into 2 into 2 into 2 into 2 into 2 and into 3 as the factors of 192. Now, find out the common basis, that is 2 how many times it is? It is 8 times. So, it is we write as 2 raised to the power of 8. and the 3 as a common base as 3 is 4 times. So, we write as 3 raised to the power of 4. So, in this way we have tried to find out the product of 108 and 192 in a exponential form, that is 2 raised to the power of 8 and 3 raised to the power of 4. So, in this way we had done the what we say as factors first, and we had tried to write in a exponential form. We will have one more example. There we were having a product of a 2 number, here we are having as a one number, that is single number, that is 270. What will be the factors of 270? We have to find out by a prime factorization method or division method and write all the factors of this 270. Now, you will find something here, we are having 2, we are having 3, even we are having here 5. So, we have to write all the factors, then we will see the common base. Here we are having 2 only a 1 time, so we write as 2. We are having 3 as 3 times, so we write 3 cube, and 5 it is 1 time, we write as 5. So, we can do the multiplication of this, it is 5 2s are 10, and we can write as 3 cube. So, this will be the answer, or we can say it is in the form of an exponential form of a 270. Now, we will see 1-2 example on a board. So, we will have a example here on the board as 279 multiplied by 64. So, we will try to solve this, how to write this product, sorry, it is 279 into 64. How to find out its product in a exponential format. So, you know we have to find out first a prime factorization. So, we will try to find out factors of this as 729 as prime factors. Now, we do not have a 2 here in the ones place. So, it is not exactly divisible by 2, giving a remainder as 0. So, what we have to find out? We have to find out the next number as 3. But you know the divisibility of 3, it is nothing but the sum of this number should be a multiple or the divisible by 3. So, here we will do the sum addition. 9 plus 7 is 16, 16 plus 2 is 18. So, 18 plus 8 plus 1 is 9. So, that 9 is divisible by 3. So, we will start with 3. 3 2s are 6. 7 minus 6, 1 is left. So, I will write here 1, that is nothing but 12. 3 4s are 12 and 3 3s are 9. Many children may face this. You can do this as division, normal division, and you can find the quotient as 3 2s are 6. Here is 1, this will be 2 here, 3 4s are 12, will be 0, get the 9 down, it is 3 3s are 9, so it is 0. What we are getting as a quotient should be written here. Now, again we will check it is divisible by 3 or not. Here is 4 plus 2 is 7, 7 plus 2 is 9, so again it is divisible by 3. 8 3s are 24 and 3 1s are 3. Now, you know this 81 can be divisible because 8 plus 1 is 9, which is divisible by 3. It is 3 2s are 6. So, 8 minus 6 is 2 will be left here. So, I will write here 2 as nothing but it is 21. So, 7 3s are 21. Here will be 3 again because it is now with a smaller number. So, you can do it's directly when it is a larger number, you can go practical division and you can find out the quotient which will be written here. So, 9 3s are 27, so 3 3s are 9 and 3 1s are. I have to rub this rough work because I want to find out some more prime factors of another number which is given as an 64. So, we will find here the 64. What are the factors of a 64? Here it is divisible by 2, yes. So, you have to try it divisible by 2 and we can find out this all the factors. This is nothing but you have to solve it by your own. If it is not possible to solve, in the next section I will try to solve this example. Just we have to find out the prime factorization of this number. Already we had I had explained you one example here. Similar example I had given here. So, please try to do it. Hope so you will get the correct answer, and if it is not possible I will do in the next session. Thank you very much.